Okay, it's time for us to get started here with some new information. I call this the foundations of logic, because in this video we're going to talk a lot about the notation that is used by mathematicians dealing with all of the truth, values, and that kind of stuff that we will deal with. This is the introduction. This is the beginning portions of it. So you're going to want to take notes. Pause the video as you need to take notes. And let's get started here. Okay, first thing I want to talk about. We want to recall from chapter 1. We have all these different terms. We want to make sure we know the definition of all these different terms. You have to understand these terms a little bit. Look at this list. If you know what every one of these words means, you're good. Move right on. If you don't, you might want to go back and check on some of them. Hopefully quite a few of them you do know. Okay, here's the big vocabulary we're going to cover in this video. We're going to talk about a statement. We're going to talk about truth value. We're going to talk about negation. We're going to talk about a compound sentence. And just like in English, we're going to have some conjunctions and some disjunctions. And then we're going to talk about a truth value. So those are the terms we're going to talk about. You're probably going to want those in your notes. This would be a good time to stop and kind of write them down. Give yourself plenty of room to write them down with, though. Okay, so our first one is a statement. What did I have here? Oh, I know what I want to talk about. Here we go. I have a statement. Raleigh is a city in North Carolina. Is that a true or false statement? Hopefully you said that's true, but if you don't know, let's take a look. Here's a map. Here's a map of North Carolina, and in North Carolina, you will notice right there in North Carolina, we have Raleigh right there. There's Raleigh, North Carolina. So this particular statement is true. True statement right there. Okay, so what exactly is a statement in mathematics then? It's real simply put, a statement is any sentence that is true or false. It has to have a condition to it. You have to be able to say, that's a true statement, that's a false statement. If it's a wavy thing, it doesn't count. So we have to have a truth statement. So what we do for this statement, that's any sentence that could be true or false, we represent that in logic notation, typically with a simple lowercase letter, such as P. So this particular statement, Raleigh is a city in North Carolina, I'm going to say that is my statement P. Now that statement had a truth value. The truth value happens to be the truth or falsity of the statement. Is it a true statement or is it a false statement? Those are the big containers of it. Now the next one is a negation of a statement. Then the negation of a statement is when you come up with the exact opposite meaning. So the negation of Raleigh is a city in North Carolina would be Raleigh is not a city in North Carolina. That would be the negation of it. Now typically our notation for a not is a little squiggly yin-yang type sign, and then you have your logic notation. Now there is a formal definition in your book, and you can find that, and it says, if a statement is represented by P, then not P, that's the negation of the statement. So our symbols is that little squiggly with the P, and we read that as not P. So I can have P, and I can have not P. Those are my two types of statements. They are negations of it. They are opposites of each other. Now what we like to do with this type of information is create compound sentences or compound statements. Well, we know what compound sentences are. Compound statements are simple, about the same. They're the joining of two or more statements. So I have a statement that's true or false, and I'm going to join that with another statement that's true or false. That's a compound statement. So let's say I have two statements. I'm going to call one P and one Q. P is that Raleigh is a city in North Carolina. Q is that Raleigh is the capital of North Carolina. Those are my two statements. Those are both true or false statements. Now, what we can do with that is we can combine them in multiple ways. One way is to say that Raleigh is a city in North Carolina and Raleigh is the capital of North Carolina. This is called a conjunction. Conjunctions are when we use the word and. So anytime I'm going to take two statements and I'm going to combine them with the word and, I'm going to call that a conjunction. Now, once again, our book has a formal definition for this. So here's our formal definition. A conjunction is a compound statement formed by joining two or more statements with the word and. Now, take a look right here. Oops, I want to use my finger. Take a look right here. We have this symbol, P with like a TP, Q. That is a symbol representing the conjunction, the and sign. It's read P and Q. Now, that's not the only symbol you'll see. You'll also see some simple U-type shapes, P and Q. And it depends on the book and the type that you can get. So either one of those, either one that's like a TP or like the U type of infinite, that goes back to like our Venn diagram information that you talked about before. That refers to as an intersection type deal. So what we have then is I can say for our particular statement here, P and Q, or I could have just written as P, the U, Q, or I could have said P with that triangle Q. Any one of these three could have been used to say Raleigh is a city in North Carolina. Now that symbol, like I said, kind of goes with the Venn diagram. Now with the Venn diagram, I can show both of these statements as their own little circles, and where they intersect, that's my area that I'm looking at. So when I look at this as a Venn diagram, I got U.S. state capitals, and I got cities in Raleigh, or North Carolina, and there's an overlap, and there's an R there because that's where Raleigh is. Okay, so a conjunction is the both parts. It has to be in both parts for that to work out. Now, the way a conjunction works, if P is a true statement and Q is a true statement, then P and Q is a true statement. So let me write that down. If P is true and Q is true, then P and Q is true. That's the only way it works. As long as they're both true, the statement's true. If P is true but Q is false, P and Q is false. If P is false and Q is true, P and Q is false. If P is false and Q is false, then they're both false, completely false. So the only way this works is if both statements are true. So we would have to have a city that is a U.S. capital. We would have to have a city in Raleigh, in North Carolina, and that would have to agree that it's Raleigh for this to be a true statement. Now that overlap area does not represent the size of answers in that grouping. It's just saying there are points of intersection, and that's true of any type thing. And the symbol we use in our Venn diagrams for intersection is that upside down U, capital U type shape. Now the other way we can compound sentences is to use a disjunction. Well, if and is a conjunction, then or is the disjunction. So instead of saying P and Q, I could say P or Q. So let's get our formal definition so we can see what it looks like. I got two statements here. I got Jericho lives in a U.S. state capital, and I have the statement that Jericho lives in a North Carolina city. So I could combine those using or, saying that Jericho lives in a U.S. state capital or Jericho lives in a North Carolina city. So I have two statements. I'm combining them this time by or instead of and. And that means huge differences. I think this is my formal definition I want. There we go. A disjunction is a common or a compound statement formed by joining two or more statements with the word or. So like before, we have a statement there. Now notice that says P looks like a giant VQ. That is read P or Q, is how that is read. P or Q. Now, like the conjunction, we could also use the other symbol, which is like a capital U type shape. It's a shape saying that we have the union of two things. So how would I write this as my Jericho lives at that? I could have said that P or Q, P with the big capital VQ, Jericho lives in a U.S. state capital, or Jericho lives in North Carolina City. Now, like I said, since conjunctions we can do with Venn diagrams, we can also do Venn diagrams for ors or disjunctions, and I have a graph that looks like this. So again, I have the U.S. state capitals. Again, I have cities in North Carolina, and I've got that overlap region. So I've got A, B, and C. Again, I have the three regions. Now, the way it works for this to be a true statement is I need the union. Instead of just the overlap as my answer, anything in either circle is the answer. So what does that mean? That means that P, if P is true, then P or Q is true. If Q is true, that's terrible writing, sorry about that. If Q is true, then P or Q is true. My lowercase p's are getting awfully large. As long as one of the two statements is true. So if it's true that she lives in the state capital, it's true. If it happens to be true that she lives in the North Carolina city, it's a true statement. If it happens to be the fact that both of them are true, so if P and Q are both true, then P or Q is true. It's just going to still be a true statement. So if they're both true, so if she happens to live in a U.S. capital that happens to be a city in North Carolina, it's still true. The only way I get a false when it's a disjunction is if both statements are false. So this gives us an idea that we need to look at a way to organize this. And the way we do that is we use what's called a truth table. I've got it right at the bottom of the screen now. A truth table is just a convenient method for organizing the truth values of statements. And that's all it is. We're just trying to organize the truth value of statement. So we'll take something real simple. Here is a truth table for the negation of P. So the first thing I do is I make a column for P, and P can be either a true or a false statement. Well, with that being said, not P would have to be false and then true. Notice P and not P are opposites on the line. So if P is true, not P has to be a false statement. If P is a false statement, not P has to be a true statement. Now we can continue this on and look at other examples, and we'll do that, but I don't want to look at the whole thing all at one time. So let's look at a conjunction and see if we can figure this out, and we'll compare it. So we have a conjunction, and the conjunction is the and. And like we talked about like I talked about, the only way I can get this to be true is if both of them are true. So the top one where P and Q are both true, that's a true statement. The second one where Q is false, that have to be false. The third one where F is false or P is false, that's got to be false. So when I look at the truth table for the conjunction, it is only true when both statements are true. That happens every single time. Now what if I looked at the disjunction? Okay, disjunction. There it comes. All right. Disjunction. If P and Q are both true, it's a true statement. If P is true and Q is false, it's still a true statement because one of them was true. If P is false and Q is true, it's still a true statement because one of them is true. Lastly, if they're both false, then it's false. That's the only time I get a false is on a disjunction. So I can use the truth values of negation, conjunction, disjunction to construct truth tables for more complex statements. So let's take a look at one right now. I'm going to make a truth table. So here we go. And first thing I'm going to do is identify what my statement is. I have P and not Q. So that's the truth table I want to make. If I want to write that out the other way, P and not Q would be my notation, or P that not Q. So any one of those is my statements. So the first thing I do when I make a truth table like this is I look how many variables I have, and I have to identify them. So I have P, and I've got Q. Well, I'm going to need not Q in my table too, so I can compare it. And then I can have my statement that P and not Q are the ones I'm looking at. So now I make a table with this value. So I'm going to switch colors. And now I have to have all arrangements that I can get. Well, my only two statements are really P and Q. Well, that means P can be true when Q is true, or P can be true when Q is false, or P can be false and Q can be true, or P can be false and Q can be false. Now, the easiest way to make that table so it always looks the same every time is the last column of variables. It alternates. The first one stays the same for a couple of terms. If I had more variables, so say I had an R here as well, I would have R go true for all four of those first terms, and then I would let R go false for the next set of terms. Anyway, so there we have our truth table set up. And all I got to do is fill in the truth table based off of the answers. So if Q is true, not Q is false. If Q is false, not Q is true. I got a true for Q, that means false for not Q. I got a false for Q, that means this is true. So now I have P and not Q. So now I'm looking at P and not Q, and I got a true and a false. Well, that's a false statement. Now the next statement, I'm looking at P and not Q. I got true and true. Well, that's a true statement. Then I have false and false. Well, that's a false statement. And I have the lastly, I got false and true. That's a false statement. So there is a truth table for P and not Q. In the assignment, it's an electronic one. I sent it to you. It should be in your folders. It's going to ask you to fill in some truth tables I had pre-made for you, and then I'm asking that you do some that haven't been pre-made for you. So you're going to have to make your own truth table on a couple of the problems. So this is, I said, this is the basics. We want to be able to take when I've gotten two statements, conjunction or disjunction, and work through them and see what I can get out as an answer. Now, to help you out, there are more problems in your book. You can see how it's done. Page 71 shows you some pretty big problems. So if you want to look in your book on page 71, they got some pretty nice examples on how to do it. They also kind of talk through on step-by-step how to make this truth table. Okay, you've got the video, you've got the basics. Start on the assignment. If you have questions, find me.